So let's walk through the development process with a simple model, view model, and view, in this case using WPF for our view application. So I've created a console application targeting .NET Core. And what this application will do is take a rock and put it in the box. Or if the rock is in the box, take the rock and take it out of the box. So let's walk through the whole process. Now I'm going to develop this to begin with as a console application as I flesh out my plan for what my model classes should look like. Because the best way to create an application that has a thin GUI is to start without a GUI and build from there. So I'm going to create a class in this project, and I'm going to call this Rock. And here's my class Rock, and there's not much in Rock. Rocks are pretty dumb. So let's just give it a name. And that's it. All right, now I want to have a box. And this box, in addition to having a name, will have the ability to either store a rock or have a rock taken from it. So that's box. It has a name that you can set. It may contain a rock. You can change the contents of the box, which is a rock, and changing those contents either means to take the rock that's in there out or to put a rock in there. So in other words, every operation is going to be, if it's full, empty it, and if it's empty, fill it. So this would be the empty box, and that would be the full box, and then you assign those contents. But if the box is already full, then you can't put another rock in. And we can check to see whether or not there's nothing in the box. So now we want to create our driver, our main program. We'll create a rock and a box and write out the current state of both. So we'll generate this method. Okay, so this will print out whether the rock is in a box or not, and it'll print out what's in the box, whether it's a rock or nothing. Now let's process some activity. All right, so this loop will execute until the user asks for an exit. It will either get the rock out of the box or put the rock in the box. And then each time it will report what's happened. So let's run this. So I can get, and the rock Skippy is out of the box wooden, and the box wooden contains nothing. If I try to get again, I get the same results because nothing has happened. I can put, And now the rock skippy is in the box wooden, and the box wooden contains the rock skippy. And I can attempt to do a put again, but again nothing happens because it doesn't change the system. Or I can exit. So now I've got a couple of model classes and a main or a driver. And my next step is to take these classes, and instead of having them in a console application, I'll put them in a library. So I'll create a library. I'll call this Rockbox Library. And instead of developing for core, which would limit its utility, I'm going to make this library .NET Standard 2.1. And now what I'm going to do is I'm going to take the source code that I used for the console and I'm going to copy that into the library. So I'll just drag box and rock down to the library. Now I will modify those for use in a library. A couple of things I need to do. I got to change the namespace for those classes. And I could use the rename tool, but since I already have something called Rockbox Console in the other console window, it's just easier to change it with copy and paste. I will also want to make my model classes public. And I don't need the class 1 class that's created with the library sort of for free. So that leaves me with my two model classes. Now rocks are pretty dumb, so I don't need to change anything about rock, but I do need to modify box so that it will work with a GUI system that uses or supports MVVM. So what modifications do I need to make to classes that have properties that are going to drive the view code, the WPF code in this case? Well, I'm going to need to notify the view about my properties being changed. So in the case of box, that means I need to implement notify property changed. And there's my new field, and then the code that we've seen before that supports a callback for when the properties change. Now I need to look around for any properties that might be changing and therefore changing the state of the view. So now I need to look through my class and find any properties that might change and invoke the property changed event procedure. Now I could put it here in set, but since all set does is call empty if full or fill if empty, I could also put it here. And the name of the property is contents. So we've got our model classes in our library, and now we need some kind of controller. Now we have one, which is our driver in the original console application, and as you can see, it creates a box and it creates a rock, and it manipulates those two objects to cause change in the system. So we need to take this behavior and put it in a controller class in our library. So I'll add a new class to the library, and this will be rock mover. And this will be a public class, and it will have a constructor that takes a rock and a box. And of course I'll need to create those fields. And then the actions associated with a rock mover, which again, you can go back and look at the main and you can see them, but they are put rock in box and remove rock from box. So now I'm ready to create my view. So I will right click solution and add a new project. And this project will be a WPF application. And I'll call this Rockbox View. So here's my WPF application Rockbox View, which represents my view, of course. So my first step is to add a reference from my library to my view. Now I want to add my ViewModel class, and I will be adding that to the WPF application. Rock box view model. And of course I want a using directive to my library. I want to make this a public class, and it will have properties associated with the model classes in my library. And of course these classes are rock and box and rock mover. And that's all that's in the view model. So now in the code behind of the XAML window, let's make use of that view model. So we'll start with a private field of type rockbox view model. And then in the constructor for the window, we will assign that object to DataContext. Now I'd like to add a resource in my XAML file so I can make use of IntelliSense in the XAML file with my view model. Now let's modify our grid. Give it a couple of rows. So let's put 3 buttons. 1, 2, 3. In the second row of the grid. And let's give these buttons names. And into those buttons, let's put 3 images, 1 for each button. So I'll select the button and drag an image to it. Now for those images I need some image files, so I'm going to right-click on the project and add a new folder, Resources. And into that folder I will copy 3 image files. And we can see them here. We have a picture of an empty box, we have a picture of a box with a rock in it, and we have a picture of just a rock. Now I'm going to arrange my image buttons a little bit. And what I've done here is I've made a superposition between button rock in box and button box, and we'll see why that is in just a little bit. Now I want to associate an image file with each of the images. So the first image would be the rock. The second image would be the rock in the box. And the third image is the box, empty. Now I want to make each of these image files resources. Right-click, Properties, Build Action, Resource. Now we're ready to add an event procedure to button rock. Go to the Properties, change it to Events, double-click on the text box next to Click. And when the user clicks on the rock, we want to put the rock in the box. So I use my view model and the mover to put the rock in the box. Now I want to do the same thing for the button rock in box. So I'll add an event procedure for it, and rock box view model, the mover, remove rock from box. My next step is to change the visibility of a control based on a value in the model objects. So what that means is I'm going to need a converter, which is to say a class that implements iValueConverter. So I've created one here, and of course it implements iValueConverter, and then the method convert will take the value from the model and turn it into the appropriate sort of value for the view. In this case, if the value returned is null, then what I want is for the visibility to be visible, and if it's not null, then I want the visibility to be hidden. Now, once you have this converter, you need to make it a resource in your XAML file. So I'll go back to the XAML file, and right after DataContext, I will add that converter as a resource. Now that I've got that resource in my XAML file, I'm ready to make use of it in my data binding. So I'm going to go to button rock and add a visibility attribute, and that will be equal to binding the box.contents converter equals static resource box empty convert to visibility. Now I want to do the same thing to another control, but in logical reverse. So I create another converter that does the opposite of what the first one does. So here it is, and as promised, it's the logical reverse. So this time if values equal null, then visibility is hidden, and otherwise it's visible. So I can go back to my XAML, create my resource to get access to the converter, and now I'll be able to make use of that converter in my binding. So I'm just going to go ahead and copy this visibility statement and put it down here associated with button, rock, and box. Paste it in here, but of course I'm going to change the converter to box has content convert to visibility. And then I will apply the original visibility statement, so I'll copy that, to the button box. So now whether or not a specific view on the control is visible is dependent upon the state of the model classes. So now we can run the code and see this in action. Here's the rock, here's the empty box. If you click on the rock, it goes into the box. If you click on the rock in the box, it comes out. So now I'm going to add a couple of additional controls to help me with the status of my rock box. So I'll start by adding a stack panel to the first row, and inside of that stack panel I will put a list view, and we'll name our list view ListView box status, and we'll create a couple of columns in our list view by modifying grid view column, and we'll make these headers, and the first column will be box, and we'll give it a width of 100, and the second column will be status, and we'll give it a width of 200. And let's make sure that this list view shows up in the grid row, and let's center everything. Now I need to establish a data source for this list view, and that data would come from the model class box. So let's go back to box in the library and add a little bit of code. And what I'm going to do is add a public field of type ObservableCollection. Of string array. And we'll resolve this namespace issue. So as the name implies, this is going to be status about the box that we can use in our view. So I'm going to want a private method that updates the contents of this observable collection, and my view will then observe it. So let's add that private method. So every time update box status is called, it's going to clear my observable collection and then determine whether or not there is a rock in the box. And if there is a rock in the box, it will include its name in the status. And then it's going to add that list of strings to the observable collection. So now I need to look at the rest of box for any place that I would need to call this method. In other words, any place the status of the box has changed. And once again, there's only one place where the status of the box changes. That's in the set part of the property. And so right after I invoke property changed, I'm going to update my box status. Now there's one other place that we might add an update box status, and that's at the very beginning. So as it stands now, we will only update the box status when there's a change, but we would like an initial condition. So I'm going to take this method and I'm going to place it in the constructor, and that way I'll have an initial condition for my list view. So that produces the data that I'm looking for. Now I have to hook that into my view. So let's go back to the code behind the view, and in the constructor, right after DataContext is set to the Rockbox view model, I'm going to set the item source property of the list view. And I'm going to set that equal to the box status of the box inside the view model. And then I go back to the XAML file, and then I make a correspondence between the columns in the observable collection and the columns in the list view. And that's done with display member binding. So as you can see here, column 0 of the list view will be assigned the first item in the observable collection, and column 1 of the list view will be assigned the second item in the observable collection. And that's it. So now we can run the application, and as you can see, the cardboard box is empty, and if I place a rock in it, the cardboard box contains the rock pebbles, and I can reverse that. And because I'm clearing the observable list each time, there's only going to be one row of data, and it is the current state of the box. If I hadn't cleared the observable list each time, I would automatically get multiple rows in my list view as my observable list grows. So let's add a little history of rock moving, and the class that would be able to record the history of rock moving is the rock mover. In rock mover, I'm going to add an observable collection as a public field. And resolve the namespace issue. So I've got an observable collection of strings which represents the history of how the rock has been moved in and out of the box. Now I need to update this every time the rock is moved, and there are two places: put rock in box and remove rock from box. So I'd like to keep a count of each rock movement, so I'll create a private field that will allow me to do that, and then record every time a rock is moved by adding an item to observable collection rock moving history. So that creates the data that I need. Now I need to hook that into my view. So I'll go back to the XAML, and in my first column, right after my list view, I'm going to create a dock panel. And in that dock panel, I'll put a scroll viewer, and in that scroll viewer, I will put an items control. And I'll name that items control. Now, just as I did with the list view, I need to assign to the item source property of the items control the observable collection that I created in the rock mover class. So now I can run the application, And we see that the status is that the cardboard box is empty. I can place the rock in the box. And the status in the list view control changes, and I have a history of what just happened. And I can do that repeatedly. In this case, because rather than clearing the observable collection each time, I'm simply adding to it.